LogRhythm's Netmon Freemium delivers real-time network visibility to quickly identify emerging threats in your IT environment. Netmon Freemium is a free, commercial-grade network forensics and traffic analytics solution. You can use Netmon Freemium's powerful capabilities to search against all observed network traffic, identify abnormal traffic patterns in application usage, and quickly analyze full packet captures. Take the first step towards real-time network visibility. Visit logRhythm.com/freemium to learn more and download it today. The SANS Institute, the most trusted source for computer security certification training and research. Visit SANS.org to explore their full curriculum and latest training offerings. Netsparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. Netsparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com. Welcome back, everyone, to Paul's Security Weekly. Oh, I have an announcement, I think. itpro.tv/Security Weekly. Use the code SW30. Try it free for 7 days. Receive 30% off your monthly membership for the lifetime of your active subscription. Michael, you and I were talking about IT Pro TV earlier on some various shows.
I find we talk about them a lot.
We do.
It's one of those things that I'm excited about. Like it's
all the time. I mean, well, there's always new content. I know that Josh Marpet and Scott Lyons are working on content. Mm-hmm. Those of you that listen to the show may know them.
Mm-hmm. Yeah, and one of the things we talked about...
And for that, I'm sorry, but I digress.
One of the things that we talked about with Tim on one of the recent startup episodes was they're branching out too, and they're going to include business-level content. So
yes.
How do you make the case for something? How do you get the budget? And I don't know exactly all the stuff that they have in there, but we were taking a look at it. What's always impressed me about it is it's not just for certifications. So what they'll say is, there's a lot of stuff happening in security today. Do you want to stay abreast of it? Okay, we'll bring people in, and they'll talk. And what they've started now is they have red team stuff and they have blue team stuff. So a lot like we were just talking with our guests, if you want to kind of get your toes into parts of what's going on or understand enough about it, there's that opportunity. And I think a lot of security teams would be really well served to listen to some of these opinions, because I think, too, we've talked to them, high-quality content produced on a regular basis. And when you look at somebody who's able to bring you high quality, but within 24 to 36 hours of being able to record it, that's a pretty impressive resource.
Yeah, the platform is pretty impressive. So make sure you check them out. Sven from Netsparker is here with us today to do a technical segment on the content security policies. Sven, welcome to the program.
Thank you. Hello. How are you?
I am wonderful. Sven, we always love it when you come on. You are a web app security ninja, and I love it when you shed light on a lot of these kind of not esoteric, but these issues that, I mean, unless you're really deep into web application security, I mean, they kind of fly under the radar. So I'm glad that we're bringing those to light in the show, and the content security policy, I think, kind of falls in that realm.
Yeah, that's true. I think content security policies are a very powerful tool if you apply it correctly. The problem is that it's not that easy, and some pitfalls are not that obvious. So you have to be a little bit careful, but if you apply it correctly, you can do a lot of great things with it.
Sorry, so what is the content security policy?
It's an HTTP security header. I prepared a presentation I can show you if you
That'd be fantastic.
If you want. I will share my screen now.
I'm prepared to have my mind blown, because last time Sven was on, he blew my mind.
Yes, I'm telling you. He's getting good at that.
I think it was Larry who did the cat joke today again. And I thought we said that we won't talk about cats anymore on the show, because it's a very emotional topic. I think after this show, we can also add Amazon fish to that list.
Yes, absolutely.
Of topics.
Fish and cats, they kind of go together, though.
They do. They do. And Chinese food.
Okay. So, I've called the presentation content security policy the last line of your cross-site scripting defense. And before I will talk about the header a little bit more, I will actually talk about why we need that header. So I would say preventing cross-site scripting is hard, and not all the people would agree to that. Some would say it's enough to just encode everything to HTML entities. Now, that isn't working for everything. For example, in an anchor text in href, you can still write this and it will be executed. So you have still an XSS vulnerability. Then you could think that you can at least use HTML entities in script blocks. The problem is that the functions who convert to HTML entities often don't put the single quote into consideration. So you have to be careful in doing that. Now, you could also think that you can just use URL encoding for everything. The problem is that browsers won't decode it for you. So if you have %3c, which is the same as the character you see here, the browsers won't decode it. You would just see %3c. So that doesn't work either. And if you think you could just block every single dangerous keyword, then you should watch Security Weekly number 526. It's just not a good idea to do that. So you probably know all of that. You know how to prevent XSS in the different contexts, but mistakes can happen. So you can try to consistently apply your knowledge. You can try to encode every single bit of user controllable output. You can sanitize your data depending on the context. But the problem is that you must be aware of every single pitfall in your programming language, as I said above, as I said before. I mean, you must be aware of obscure edge cases, some flash stuff that's not immediately obvious, and all that stuff. And you must never forget to apply your sanitization function. Of course, you also have to think about the required parameters, for example, to encode the single quotes. And if you forget one of those things just once, you end up having an XSS vulnerability. And you might think that shouldn't happen very often with seasoned developers, but the truth is that it even happens to the best. So Google, a company that spends obscene amounts of money on security, receives reports about XSS vulnerabilities on a regular basis. And it's just because you can't catch everything. The same goes for Twitter, for example. Now there's where the content security policy comes into play. It's short, CSP is short for Content Security Policy. And the short answer is that it's another HTTP security header. The long answer is that it's an HTTP response header called Content Security Policy. And it has many different directives that define where content is allowed to be loaded from, what kind of content is allowed to be loaded from, what kind of content is allowed to be loaded, and most importantly, in which context scripts can be executed. So there are different kinds of source expressions. I will go into detail about them later, but here are a few of them. For example, if you use none, then nothing is allowed. You can load nothing, and self is just from the same origin. Then a link like this, https example.com, allows only resources from example.com to be loaded. And most importantly, even Firefox supports it. So how may a CSP header look like? And this is an example. So you actually already see that it's a little bit confusing. So we'll go into detail about the different components. The first one is just the name of the header, Content Security Policy, and after that, the actually policy follows. For example, default SRC. It's used as a fallback for some missing directives. If you don't specify everything, most of the directives will fall back to default SRC. And none blocks everything by default. So script SRC is very interesting for us because we can use it to actually control where scripts are allowed to be loaded from. And self, again, allows the inclusion of scripts from the same origin, and https example.com allows script inclusions from there. So you actually see already that you can write different source expressions behind that in one line. And yeah, so how does this prevent XSS, you might ask? It does so by whitelisting origins and context. And there are different ways to restrict script execution. You can do it inline with nonces. Those are random strings that you have in your header and in your script tag, and they allow you to only load the inline scripts where the nonce is defined. And an attacker can't know the nonce. It's like similar to CSRF protection from the concept. Then, of course, you can also use hashes. You can generate a hash from your script, from the content of your script log, and only those hashes, only the scripts that hash to the value that you specified are allowed to be loaded. Then there's unsafe inline, and there we have one of the first mistakes you can happen. Unsafe inline will be I will talk about that a little bit later too.
So Sven, I'm sorry. So this is really only for reflective cross-site scripting, right? Where I'm the attacker and the source would be my client trying to execute a script. But if I'm able to manipulate the application and put code inside of it that gets executed within the application, that source, potentially the nonce and the hashes would match as well, correct?
Well, the hash, that depends, I think. For example, the hash wouldn't match if you change anything in the script log.
Oh,
that's
okay.
kind of the point of that.
Yep.
And even stored XSS can be prevented with CSP.
Mm-hmm.
So you can also restrict where external scripts are allowed to be loaded from. For example, with self, HTTPS, and data. And you see the red ones are like unsafe keywords that you shouldn't really use. So you can also use HTTPS example.com. We had that before, and you can also use this wildcard character for subdomains. So any subdomain of example.com would be allowed to be included, every script in there. So what can go wrong?
Nothing.
They're common.
Oh, wait. Never mind. Sven's on talking about it, so clearly lots of things can go wrong.
Yes.
Yeah, that's true. So a common mistake is unsafe keywords, and depending on the context, there are words that should be avoided. For example, unsafe eval, unsafe inline HTTPS and data, they are quite deadly for every CSP policy most of the time, because they defeat the whole purpose of CSP in most cases. For example, script SRC self unsafe inline. And you can bypass that just with script alert warn script.
Mm-hmm.
Because it just kind of disables the rest of the policy. And then you have script SRC self data. Then you can bypass it like this. Okay, so it's not really about very clever bypasses. It's just about what you allow the attacker to do, basically, where content is allowed to be loaded from. What can go wrong? Number two, relying on default SRC. It's a good way to avoid mistakes, but not every directive will be caught by default SRC if you omit it. For example, if you have default SRC self, you can still inject like this, a form that sends your password somewhere else.
That requires a lot of code though, and typically you're restricted as to the amount of data that you can inject, correct?
Yeah, that is kind of true. I mean, it depends on where the injection is and if there's even a length limit. Like you would probably do this with most GET-based XSS.
Mm-hmm.
So it's not that big of a problem, but it's very obvious in the URL. And of course, we have common mistake number 3, wrong use of nonces. And you like with everything cryptography related, you can do a lot of stuff just plainly wrong. And first of all, the nonce must be a random string. It must not be reused, and it should be sufficiently long. So I have an example about bad nonces. For example, request 1 and request 2 are the same. Then a very, very short
one.
nonce. And this one looks very good at the first look. It's long enough, actually. 128 bits, but the problem is that it's just the MD5 of 235, so it's kind of like pointless to use it. And often the best security features are the hardest to get right, and I just shed a little tear right now when I think of HPKP, because I really liked it and now it's gone. It's a shame. But anyway, let's continue. Some other common mistakes are the syntax. If you miss single quotes, it means some directives won't work. And this can be a problem in certain circumstances. Meta tags, and some directives are not allowed to be set in them, and that is a problem as well if you rely on meta tags. For example, I think you can't set a report URI with them. Then you're going to have a bad time, because no CSP report will ever arrive, because it just doesn't work. And you can also use unsupported algorithms. Only SHA-256, 384, and 512 are allowed to be used in hashes. And I will show you a demo of some of these, of how CSP works, basically. I've prepared a little test page for this. You can see here I hope it's big enough.
Yes.
Okay. You can see here different directives, default SSC, script SSC, and so on. And if I type it here, it will be applied to this test page over here. Right. So we also have a hash generator to show how to use the hash, and we can also add additional content to the to the page. And we can also see CSP reports. So what I first want to do is set the default SSC to none to show you how that might look like. Okay, so it's pretty ugly. Like nothing is allowed to be loaded. You don't have any scripts or anything. No images. Just nothing is allowed to be loaded. It's pretty ugly, and therefore it's very secure. Mm-hmm. But I think nobody would visit your website anymore. So what's way better is to set the default SSC to self. So everything works again. But now, if I would try to, this is just a reflected exercise. If I would try to inject my own script, it would be refused. It doesn't work. It just that's only allowed to load scripts from the same domain.
Right, but that's going to break things like if you've got any kind of Google Ads or Google Analytics, which are very popular to have on your site, that would break that, essentially.
Exactly. I don't know if they are CSP, like if you can use them with CSP, I guess you can. You would see a lot of Google URLs in the CSP directives on the popular website.
Right.
So just to show you what you could do is script SSC script.js script add content, and I hope it worked. Let me check. Oh yeah. So I don't know if you see it, but it says local script. So local script executed. It's on the same domain. Now, but that is probably not really the reality of most sites. In most sites, you have just really ugly script blocks with a lot of stuff in there. So let's do this again. Local script, add content, and now you see where the problem is, because a lot of sites just have these inline script blocks. and you can't have both. You can't block the attacker script block and your own script blocks at this and don't block your own script blocks. It just the browser can't can't distinguish between the two. So what you actually can do then is as a C-self, and then use your nonce, and then it's just a random value. And what you would do here is type in nonce, and then just the same nonce value as before, right? So if we try it this time, it just works because we have the same random value.
Mm-hmm.
It's here, this one, and yeah, this works, but the attacker script is still blocked. So let's just check an unsafe, or just no security policy at all. If we would scan it with Netsparker, we would see that it just warns you that there's not a content security policy implemented, which is obviously bad. Now, as I said before, you have probably these script blocks here, and you can have a very, very good content security policy, like here yourself, script as a C-self, and then just only allow, for example, https example.com, and maybe all the subdomains as well. And there you have a problem, okay? You can still not, you can still not execute your inline script, and a lot of developers will just they will just not. They will go crazy, basically. So they see this stuff works, all the external scripts work, but the local scripts don't. And what they will just do is they do this unsafe inline, and they say, oh, well, it works great. Now my script works, everything is fine, but also the attacker scripts work too. So you have all your great directives and did everything correctly, but then you have an unsafe inline and ruin the whole thing. So if we would quickly scan this again.
Ain't nothing safe about unsafe inline.
Yeah.
It's a great t-shirt, Larry.
So Netsparker would also tell you that you're doing something wrong. For example, the unsafe content security directive,
Nice.
content security policy directive. So it's very handy. You can do a lot wrong, and it's just a great way to check it. Great. Now to see what you can also do except of nonces, because they're sometimes bypassable. They were bypassable in the past by using SVG and animations and stuff. It's a little bit complicated, but it was a very cool trick. I won't show this today because it doesn't work with modern browsers anymore. Mm-hmm. But I can quickly show you how such a hash works. So we have this here alert local script. I don't know if I did that already. And then you just generate the hash here. Okay. And what you do again here is using self self here, and this time SHA-256, I think, was it? And yeah, so it works again. So it's pretty handy to prevent all of that, all of the attacker control stuff. But I think you want to see some cool bypasses again. So I just show you one very common one that can be abused. If you have that on, if you have something like this on your local domain, or any whitelisted domain actually, if you have something like this, it looks very innocent at first. So it's just some JSON. But what you can actually do is, using a callback parameter, And then you see it's just actually JSON-P or JSON with padding. Now what this would do is if you define your function ASD and then include this here, this object would actually be passed to ASD, to the function, and you could do anything what you want cross-domain. But what you can also do, since this is some whitelisted script actually on the same origin or on a bypass on a whitelisted origin, is you can write your payload like this. Then you go there. Let's just make this here self. And this doesn't work anymore. But if you were an attacker and would then include script SRC, and then this JSON-P endpoint, you can actually bypass that. So you should be really careful about those JSON-P endpoints. You should really take a look at the whitelisted domains that you have, and and that they don't contain such unsafe endpoints. Now, what I can also quickly show you is CSP reports. They are quite useful actually. If you type here report.php and then have this here, you will actually receive a CSP report that looks like this. So you can see everything what happened and which line it happened, and why it was blocked. So it's very handy to actually confirm that your script directive is working correctly, and you can also very early detect people that try to abuse an existing XSS vulnerability that just doesn't work due to CSP.
Oh, so Sven, how did you get that CSV report?
Okay, that's actually one of the directives here. It's the report URI directive, and you can just just type in report PHP. It will just this page you will fetch the.
Oh, I see. Okay, so you dump that report to a page in the directive for the CSV policy.
Yeah, that's just some JSON that I stored and then retrieved on this page again.
Gotcha.
But you can store it actually in a database and write yourself some code that notifies you if a CSP report is sent, and therefore if...
Right, and you only make it available on the back end and not in the front end application, obviously.
Yeah, exactly.
No, that's awesome.
Okay, that's about it, I think. Do you have any questions?
Questions, folks?
Negative
Questions from the audience?
But my mind is blown continuously by Sven.
That's right. Everyone that does web app pen test, take note.
Yeah. The last time Sven was on, we were watching. I was literally texting to our guys like, "Why aren't you watching this?"
Yes, you should be watching this.
Yes, and I would also argue the same for this one.
Absolutely.
Yeah.
Well, Sven, thank you so much. Sven works at Netsparker. You should definitely check them out for your web app scanning needs, for sure. And we love it when Sven comes on and drops knowledge with us, as he's done consistently, and this is no exception. So, Sven, thank you again.
Thank you very much.
With that, we'll take a short break, come back, talk about the security news for this week. Stay tuned. Don't go anywhere.